Hi everybody, and once again welcome to Pankaj's Echelon Tutorials. In this today's session we are going to deal with sine rule and cosine rule, which is for the IGCSE international students. Okay, so this video is meant for IGCSE international students or international math students. Okay, and today I'm going to deal with this sine rule and the cosine rule. In the last video, I think I had discussed about the bearings. In continuation to bearing, now I'm coming to something called sine rule and the cosine rule. Now, what is this sine rule and the cosine rule? Of course, today I'll be dealing with only the sine rule. Okay. So far in your school, in your mathematics, you must have limited your trigonometry to a right angle triangle. Okay, what I mean to say is when you want to, suppose there's a right angle triangle like this. Okay, yep, one second. Yeah, so suppose you have a right angle triangle, say ABC. Okay, so this is a right angle triangle and it is a right angle at B. Okay. So either you take this angle or this angle, you can always find out say X and Y. So you can always find out all the trigonometric ratios of this X and Y. So you can find out sine of X, you can find out cos of X, you can find out tan of X, you can find out sine of Y, cos of Y, tan of Y, etc. Okay, this you have studied so far. Okay, now I don't want to go deep into this. You know how to find out this. Okay, now if I ask you, what if a triangle is not a right angle triangle? Still trigonometry works on it or not? So the answer is yes, trigonometry still works on it. But for that, you will have to extend your knowledge and you will have to take a bit forward by understanding what are sine rules and cosine rules. Okay. So in this today's session, I want to take you to a next level of trigonometry, and that is what happens if a triangle is not a right angle triangle. So suppose you have a triangle like this. Okay, now you can see this is not a right angle triangle, right? Suppose you have a triangle ABC in this way. This is A, B, and C. Okay, now if you want to find out the uh, okay, now if you want to find out, suppose these are angles, A, B, and C. Let me take this as again angle 1, 2, and 3. Now, if you want to find out sine 1, sine 2, sine 3, and all that stuff, okay, the trigonometric ratios of these angles, okay, then you will be in a fix because you know so far that trigonometry works only for right angle triangles. So, from now onwards, let me teach you how to find out the trigonometric ratios of angles which are not right angle triangles. So, suppose you have a scalene triangle like ABC, okay. Now there's one more scalene triangle shown here in this figure ABC. Okay. So we are going to refer to this particular diagram and try to understand what is sine rule. Okay. Now suppose you have this particular triangle. Now this is a triangle which we will have to deal later because here you have a obtuse angle over here. Okay. This angle B is obtuse. So let us not go for this one. This one also you can of course uh, find out all the trigonometric ratios of all the three angles. But then let us now take this particular triangle, which is a acute scalene triangle. This is not an acute scalene triangle. This is a obtuse scalene triangle. So let us not do this first. This we'll do later on. Okay. So what I'll do is we'll have to just take this triangle and see how we can find out the sine of angle A, B, and C. So looking at this triangle, you can see it's a triangle ABC, which is a scalene triangle. Okay. You know what is a scalene triangle? Triangle ABC is scalene. Scalene means all the three angles are not equal. Okay, so you can see these are not all equal. At the same time, all are acute. Okay, so it's a scalene triangle, but an acute scalene triangle. Okay. Now, in this triangle ABC, if I happen to make a altitude CX, okay, altitude CX on side AB, okay, then this triangle ABC will now be divided into two triangles, a smaller triangle ACX, okay, another smaller triangle BCX, isn't it? When I draw this altitude Cx perpendicular to AB, I get two more triangles, one ACX and one BCX. Okay. Now these two triangles are nothing but right angle triangles. Okay. Because I have drawn CX perpendicular to AB. Now what happens in this triangle ACX, that is this chota triangle. Okay, this triangle, right? ACX. In this triangle, if I want to write an expression for sine A, I can easily write it as opposite upon hypotenuse. So sine A in this triangle ACX, okay, I'm talking about this triangle. In this triangle ACX, sine A will be opposite upon hypotenuse, which is nothing but h upon b. Now, if I want to rearrange this, I can write h is equal to b sine A, right? Now, the same thing I can do for this triangle BCX. BCX is over here. This is my BCX triangle. In this BCX triangle, if I want to find out sine B, an expression for sine B, then it would be sine B expression will be opposite upon a hypotenuse. So opposite is h and hypotenuse is a. So can I write as h upon a? If I rearrange this, I get a sine of a B is equal to h, right? Now, if you compare these two statements, 1 and 2, you will see both are having on the right hand side h, okay, or rather whatever it is. So this is h equal to a sine b and this is h equal to b sine a. So we can say that b sine a is equal to a sine b, okay. And from this we can write as sine a upon a sine b is equal to a upon a b, right? Now this can be rearranged and it can be written as even this way you can write a upon sine a equal to, see this is a and this sine a I will bring below that a, okay, this will be equal to b upon a sine b. Now this way also you can write. Now this is something which is known as a sine rule. This is something which is known as a sine rule. Now whatever I have done in this particular triangle ABC, okay, to get this particular sine rule, a upon sine a equal to b upon sine b. Now this can be extended by taking this altitude Cx not on side AB, we can draw that altitude on side BC. So similarly, just what we did within this triangle, this also we can do, okay. We can draw the altitude AY, okay, on the side BC. And when you do that, again, you will get a relationship now between uh, this B and C, okay. So you will get this particular relationship, okay. So I'm not going more in detail. You can do that for your own, okay. And using this C altitude drawn on this BC, you will get, so I'll write here similarly, we can get, okay, this particular expression, that is B upon sine B equal to C upon sine C. Okay. Now this small ABC are nothing but the sides of this triangle. Okay. And capital A, B, and C are the angles of this triangle. Okay. So don't get confused between this small c and the capital C. Small c is the side and capital C is the angle. So this can also be derived in the same way along the same steps. Now, if you take these two things together, you can write it as a upon sine A equal to B upon sine B. And because B upon sine B is equal to C upon sine C, so you can write that also as C upon sine C. This is something which is known as the sine rule, and this sine rule will help you. This is known as the sine rule. And can you see this sine rule is applicable to triangle which is not a right angle triangle. This was a scalene triangle, isn't it? So this sine rule can be used to find out the sine of a angle A or B or C, whatever the case may be, provided you should have the other information as well. Okay, so that was sine rule, and how the sine rule is derived, that I have tried to explain. Now, suppose you had a obtuse scalene triangle, not a acute. Okay, so what can be done? Still the sine rule works? The answer is yes, the sine rule still works. So let us see and let us derive the sine rule for a obtuse scalene triangle. Okay, now this is the diagram that you will be following. Okay, right. Now this is for obtuse scalene triangle. Now can you see this triangle ABC shown over here? This triangle ABC. This is a obtuse scalene triangle. So now we are deriving the sine rule for obtuse scalene triangle ABC. The diagram is right on the right hand side over here. ABC, the purple triangle you can see. That is your obtuse scalene triangle. Now, in this obtuse scalene triangle, suppose you want to draw the height of this triangle, and that height is say CD, okay, and this CD is perpendicular to the AB. Okay, so you'll have to extend this AB in the backward direction, and you'll have to draw this CD perpendicular to AB. Okay, so when you draw CD perpendicular to AB extended, and write AB extended, okay, you get this entire triangle, and now you get two triangles. Okay, when you do this, you get two triangles. One is your triangle BCD, which is a right angle triangle. Okay, and you get one more triangle, that is ACD. Now both these triangles are now right angle triangles. Okay, so can you see this is that first triangle ABD? Okay, the non-purple triangle ABD, or you can call it as BCD. Okay, that is this one, and you get a bigger triangle ACD. Okay, this one. So these both are right angle triangles. Now, by the trigonometry of right angle triangle, now assume that you are onto this triangle ACD. Okay, this triangle. So in this triangle ACD, okay, that is this one, bigger triangle ACD. What will be your sine A? So sine A will be equal to opposite, that is H, upon hypotenuse, that is AC, or you can say B. So can I write this as H upon B? Now if I rearrange this, I can write H equal to B sine of a A. Okay, I get H equal to B sine of a A. Now coming to this smaller triangle BCD, okay, the non-purple triangle BCD. Right, in this, suppose I want to write down an expression for sine B. So sine B can be written as, now we are into this smaller triangle, so sine B will be equal to opposite, that is H, upon the hypotenuse. Now hypotenuse of this BCD triangle happens to be A, so I'll write a A over here. Now this, if I rearrange, I'll get H equal to A sine of a B. Now again you have a situation where you have two expressions for H. So I can write A sine B is equal to B sine of A. Now if I rearrange this, I can write A upon sine A equal to a B upon sine B, isn't it? So for an obtuse triangle, obtuse scalene triangle, also we can derive this sine rule. Now, in this case, we had drawn the hypotenuse. Okay. Okay. Here, this will not be sine B. Okay, this sine B, is actually 180 minus B. This is not sine B actually. You should not get confused with this sine B. This sine B here, in this case, this sine B. This angle is this one, okay? 180 minus B. This B is actually 180 minus B. Okay, so you can write this as A upon sine A equal to B upon sine of 180 minus B. Okay, but by trigonometry, if you follow the graph of a sine function, okay, you will find that sine of 180 minus B is same as sine of B, and that is why we can take sine of 180 minus B as sine B only. So our sine rule works in this case also. It will be A upon sine A equal to B upon sine of 180 minus B can be written as sine of B. Now to understand why 180 minus B and sine B are both same, sine of 180 minus B and sine B, why these two are both the same, so that I'll try to explain you from the graph of a sine function. Now can you see this graph? This is a graph of a sine function. Now suppose I want to draw a graph of a sine function, something like this. Okay, so this is my 0, this is my 90 degree, this is my 180 degree, this is my 270 degree, and this is 360 degree. Okay, now this is a function y is equal to sine A, right? I've drawn a graph of y is equal to sine A. Now what happens is sine of some angle B, acute angle B, suppose this is that acute angle B. Okay, so sine of this B, if I want to find out, then what I'll do is I'll draw this line this way and I'll come over here on the y-axis. This is my answer. Okay, so sine of B will be equal to this x, right? So can I write sine of B equal to x? But if I come to this point over here, here also I am getting x. Okay, so this, if I come down, this particular angle, whatever this angle will be, that also has a sine value as x. So sine of this something is also equal to x. So you can see that the angles, the sine value of the angles is repeated after a certain interval. Now if you see by symmetry, can you see this triangle and this triangle, the shaded triangle? Can't you see that both are similar, exactly the same? Okay, so this particular distance and this distance will be same. Okay, now this is from 0 to B, so this is distance B or angle B, so this has to be 180 minus B. Okay, this distance will be 180 minus B. So can I write here 180 minus B? So sine of 180 minus B is also x. Now if you see, both the right hand side are x, so I can say that sine of B is same as sine of 180 minus B. And that is why here in this formula where it was actually sine of, now here let me write it as 180 minus B so that you don't get confused. Okay, this B is not actually this BCD, no, in triangle BCD. Yeah, this is this has to be 180 minus B. Okay, sine of 180 minus B. Okay, right? Okay, now because sine of 180 minus B and sine of B is same, okay, this sine of 180 minus B over here I have replaced with sine B. Okay, and that is how you get this sine rule, which is same as applied to the acute scalene triangle. So for whether it is acute or obtuse scalene triangle, this same formula works. Okay, now same way, if you want to prove, you can also prove this, that is b upon sine b is equal to c upon sine c. Okay, this can also be proved in the same way. So ultimately you will get a upon sine a equal to b upon sine b equal to c upon sine c. Now this happens to be your sine rule for your obtuse scalene triangle as well. Okay, so we have proved that sine rule works for both obtuse as well as acute scalene triangle. Now this completes the sine rule explanation, how sine rule is derived. So whether it is an acute triangle or an obtuse triangle, whether it is a right angle triangle or scalene triangle, this sine rule will always work. So to summarize, what is a sine rule? So whether it is a scalene triangle or whether it is a obtuse scalene triangle or acute scalene triangle, like for instance, this is obtuse scalene triangle, and this is acute, and this is obtuse. Okay, so whether the triangle is like this or like this, okay, the sine rule says that sine a upon a equal to sine b upon a b equal to sine c upon a c. Now this can be written in the other way also. A upon a sine a is equal to b upon a sine b is equal to c upon a sine c. Okay, your angles are capital ABC, right? Capital ABC, and your sides are small ABC, right? The sides are small a, b, and c. Okay, so that was sine rule, and if you want to solve some problems on sine rule, we can do that, but that we will be doing in the next session, and this is what we'll be doing to solve some problems related to sine rule, but that I'll be doing in the next video. That's all for today, and see you in the next video. Till then, goodbye, and take care all of you.